Welcome to our lesson today. My name is Purity Anzelimo, and our topic for today is differentiation. Our subtopic for today is the application of differentiation. Application of differentiation. Application of differentiation in calculation of acceleration. In the calculation of acceleration. Application of differentiation in calculation of acceleration. In the previous lesson, we were looking at how we apply differentiation in calculation of velocity. Calculation of velocity. And we said that when we want to calculate the velocity, it is simply the differentiation of the distance with respect to time. So velocity is ds all over dt, where s is the displacement, and t is the time. T is the time taken, and therefore velocity is ds all over dt. Again, when you want to calculate the displacement at a certain point, you simply need to substitute the values of time with the given value when you have the equation for displacement. For example, when you have an equation like s is t cubed minus 4, and you are trying to find the displacement when t is equal to 2 seconds. You just need to come and substitute t with 2, and you are able to get the displacement s. So in this lesson, I would like us to look at application now of differentiation in the calculation of acceleration. Now in this case, when we consider a body, moving at a velocity v meters per second, and taking in time t seconds, given by the equation, we consider a body moving at a velocity v meters per second in time t seconds, and we have given by the equation, for example, let's say we have v equal to 2t minus or plus 3. v equal to 2t plus 3, or we can have 2t squared plus 3t. And we have that as the equation for velocity. V is the velocity and t is the time. Now we know very well that whenever we have a graph, of velocity, against time, the slope for a graph of velocity against time, the slope, that is from linear motion, or the gradient, will give us the acceleration. It gives us the acceleration. Or simply, we know very well that change in velocity per unit time, change in velocity all over change in time will give us the acceleration. We talk of acceleration A. It is equal to the acceleration A, which is the symbol that we are using here for acceleration. Meaning that the gradient of a velocity time graph gives us the acceleration. And the gradient is given by the change in velocity all over the change in time, which again, the gradient from our equation can be given by the dv all over dt, because this is the gradient function. And this gradient is what we are saying is equal to the acceleration A. And therefore, by differentiation, acceleration A is equal to dv all over dt. Acceleration is equal to dv all over dt. And this will give us the acceleration. So when we want to get the acceleration here, we simply differentiate this equation with respect to t, because our acceleration is dv all over dt. Since gradient of a velocity time graph is equal to the acceleration, and gradient, that is now the gradient function, will be given by dv all over dt. We can do some examples for calculation of acceleration when we have been given the equation. So we can do some few questions on that. So in example number 1, examples number 1, in this question we are told find the acceleration, find the acceleration at the times t is equal to 1 and t is equal to 2 in each of the following, in the following equation. And the equation that you have been given is that v is equal to 5 plus 5t minus t squared. So we want to get the acceleration at the times when t is equal to 1 and when t is equal to 2 in the following equation. So in our case, we are not told whether it is seconds or maybe in minutes, so we just give our answer. So in this, acceleration is given by dv all over dt. So we get the gradient function, we differentiate this equation, so we have dv all over dt is equal to, differentiate the constant, we get 0. This one becomes, we have 1 times 5, we have 5, t1 minus 1, then minus 2 times 1, we have 2t squared minus 1. So we have 5 minus 2t. That is the dv dt, which is equivalent to the acceleration. So acceleration is equal to 5 minus 2t. We want to get the acceleration when t is 1. So we simply come and now substitute the values of t, we substitute with 1. And therefore we are going to have the acceleration, we have therefore the acceleration, we have the equation is equal to 5 minus 2t, when now at the time when t is 1, so we have a to be 5 minus 2 and our t is 1. So the acceleration here will be 5 minus 2, that is 3. So the acceleration is 3. And again, we get the acceleration, we have the equation 5 minus 2t when t is 2. When t is 2, again we have our acceleration as 5 minus, we have 2 multiplied by t, and our t is 2. So we end up getting our acceleration as 5 minus 4, that is 1. So the acceleration is equal to 1. So when you are finding the acceleration, when you are given the equation for velocity, you need to differentiate. And then when you are finding now the acceleration at a certain point, You just substitute the values of t with the value that is given, and you'll be able to get the acceleration. Example 2, whereby you are calculating again the acceleration. Example 2, we've been given the following. A particle moves in a straight line. A particle moves in a straight line such that its velocity v meters per second after t seconds is given by the following equation. V is equal to 3 plus 10t minus t squared. And the question is A, find the acceleration. At 1, we have at t equal to 1 second, and number 2 at t equal to 3 seconds. So we need to calculate the acceleration when time is 1 second and when time is 3 seconds. So a particle moves in a straight line is such that its velocity is v meters per second after time t seconds, and is given by that equation. So we want to find the acceleration at t equal to 1 second. So in this again, we first need to write the equation that will give us the acceleration. We have the equation for velocity v equal to 3 plus 10t minus t squared. So when we want to get now the equation for acceleration, we need to differentiate this. We get dv all over dt, which is equal to the acceleration. So this one will be then the gradient function of a constant is 0. Then we have plus, here we have 1, so we have 10t1 minus 1. Then minus 2 times 1, we have 2t squared minus 1. So we get that acceleration therefore is equal to 10 minus 2t. That is the function for acceleration. So acceleration when t, so we have the equation A is equal to 10 minus 2t, and therefore when t is 1 second, we have our acceleration as 10 minus 2, our t is 1. So we have 10 minus 2, that is 8. And because in our case we have the units, velocity meters per second and time in seconds, therefore our unit for acceleration will be meters per square seconds. Because as we know, acceleration is change in velocity all over change in time. And velocity is in meters per second, time is in seconds. So we have meters per square seconds. Then again, we need to get the acceleration. We have 10 is equal to 2t. We will need to get the acceleration when time is 3 seconds. So our acceleration will be 10 minus 2, and our t is 3. So we end up getting 10 minus 6, which is equal to 4 meters per square seconds. That will be our acceleration. That is 4 meters per square seconds. Then finally in that question, part B of the question, in part A we are finding the acceleration when t is 1 second and when t is 3 seconds. So part B of the question, part B of that question, we are told to calculate the following. So number B, find the instant at which the acceleration find the instant at which the acceleration is 0. Find the instant at which the acceleration is 0. Now we need to note very well that when the acceleration is 0, it means that the gradient is 0. When acceleration is 0, it means that the gradient for the velocity time graph is 0. The gradient is 0, and the gradient is dv all over dt is equal to 0. So we need to get the dv dt, we equate to 0 so that we can get the instant, the time at which the acceleration is 0. So we have the dv dt, we have it here, which is 10 minus 2t. So our dv all over dt is equal to 10 minus 2t. So our acceleration is 0 when the gradient function is 0. So when it is at 0, when acceleration is 0, when a is equal to 0, we have 10 minus 2t equal to 0. So we find the value of t. So we'll have negative 2t is equal to 0 minus 10. So negative 2t is equal to negative 10. We divide by negative 2 by negative 2. And therefore time will be equal to 5 seconds. So this is the instant at which the acceleration of this particle is equal to 0. So that instant is when time is equal to 5 seconds. When time is equal to 5 seconds. So another example, we can do an example 3. Number 3. Example 3 for the application of differentiation in calculation of acceleration. We are given a particle moves in a straight line. A particle moves in a straight line such that its velocity v meters per second after t seconds is given by the following equation. V is equal to 4 plus 8t minus t squared. So the question is asking find the acceleration. At t equal to 10 seconds. At t equal to 10 seconds. So I want us to find the acceleration in this question. A particle moves in a straight line such that its velocity v after t seconds is given by this equation. Find the acceleration at t equal to 10 seconds. Again, in this, we want to calculate the acceleration. And we have seen when we want to calculate the acceleration, we find the dv all over the dt. We differentiate this equation with respect to t. And therefore, our acceleration, therefore, will be equal to dv all over dt. That is, we differentiate 4, we get 0, plus, we have 1 here, we have 8t, 1 minus 1, then minus 2 times 1, that is 2t squared minus 1. So we have our acceleration as 8 minus 2t. That is the acceleration. And therefore, we now want to get the acceleration at this instant when t is 10 seconds. And therefore, when t is equal to 10 seconds, so we are going to equate this, we are going to equate acceleration to this, where t we substitute with 10 seconds. So our a will be 8 minus 2 times 10, which will be 8 minus 20. that is negative 12 meters per square second. So our acceleration is negative 12 meters per square seconds, meaning that when you have acceleration as negative, when the acceleration is negative, when A is negative, it is referred to as deceleration. It is referred to as deceleration or retardation. When you calculate and find that the acceleration is negative, it simply means that this body is slowing down. Maybe it was moving at a velocity of 10, then it moves down to a velocity, for example, of 2 meters per second. Then it means that the acceleration will be negative, and therefore it is referred to as deceleration or retardation. So our retardation in this question, or our deceleration, which is our retardation in this question, therefore, will be equal to 12 meters per square seconds. The negative shows that it is a deceleration, and therefore the deceleration is 12 meters per square seconds. I want to give you an assignment, an exercise for you. Exercise. I want you to do the following exercise. Question number 1. A stone is thrown vertically, upwards, such that its height, in our case here we have the height, its height S meters above the ground, after t seconds, after the time t seconds, is given by the following. S is equal to 40t minus 10t squared. Find. So you can see in our case here we have the height S meters, so our height is the distance. That height is the distance. So find A, its height above the ground, after 2 seconds. So that's the first one. Calculate the distance or the height above the ground after 2 seconds. Then part B, its velocity. You calculate its velocity after 1 second. Its velocity after 1 second. Finally, the instant, number C, you calculate the instant at which the stone is 30 meters high. So whenever you hear of the instant, it simply means the time at which the stone is 30 meters high. And question number 2 that you need to also solve, question number 2, you've been given a ball, number 2, a ball is kicked upwards and after t seconds, ball is kicked upwards, and after t seconds, its height h meters, its height h meters is given by h is equal to 1 plus 60t then minus 18t squared. That is the equation for the height. So the equation is find its height, need to calculate its height, comma, velocity, its height, velocity, and acceleration. So you need to calculate the height, that's 1, then the velocity and acceleration. You calculate the 3 of the ball when at the following instant, when t is equal to 1, then when t is equal to 3, and number 3 when t is equal to 1, 2 over 3. All these are seconds. 3 seconds, 1, 2 over 3 seconds. So you ensure that you do these questions, calculate here the height, the velocity, and the acceleration. And by so doing, you'll be summarizing the whole sum topic, that is application of differentiation in calculation 1 of displacement, 2 velocity, and 3 acceleration. So to summarize all this, that is the application of differentiation, you need to note very well that when you want to calculate velocity, it is simply ds all over dt, where s is the displacement. It can still be the distance, it can still be the height, it can still be the length, all that. Then t is the time. Then again, when you want to get the acceleration, it is simply dv all over dt, where our a, this is v is the velocity, Here our a is the acceleration, and v is the velocity. Again here t is the time. So you differentiate velocity, the equation for velocity, with respect to t. Then you differentiate this equation again with respect to t. So that's how we calculate velocity, ds dt, acceleration, dv all over dt. Thank you. Let us meet during the next lesson.